Hey, 6th grade. In this video, we're going to continue talking about area, and this time we're going to look at the area of triangles and trapezoids. So I want you to look below at this figure. I have drawn here a rectangle, but this would apply to any parallelogram. If I draw the diagonal of a parallelogram, you'll notice that it divides the parallelogram into two congruent triangles. We have a blue triangle and a red triangle there, and those triangles are both congruent. If I wanted to find the area of one of those triangles, the area would be equivalent to half the area of the entire parallelogram. And so that's where we get the formula for the area of a triangle that we're going to talk about down below. The area of a triangle is going to involve two dimensions, the base of the triangle and its height. The base of a triangle can be any side of the triangle. The height of the triangle is the perpendicular distance from the base to the opposite vertex. So for example, if I were looking at the blue triangle that I have drawn here, the base of the triangle could be this side here. If this is the base, then that means that this side has to be the height, because again, the height is the perpendicular distance from the base to the opposite vertex. This would be the vertex opposite the base. For the red triangle, I could call this side the base. If that is the base, then that means the height is this side here. Okay, so depending on what side the question refers to as the base, that determines which side or what the height is going to be of the triangle. So the formula for the area of a triangle is going to be 1/2 times base times height. And again, that's because if you divide a parallelogram in half using the diagonal, the area of the triangles are half that of the parallelogram. So we take our formula for area of a parallelogram and then we multiply it by 1/2 to get the area formula for a triangle. Notice that sometimes the height is not an actual side of the triangle. Sometimes it's just an imaginary line that we draw in. Again, the distance from the base to the opposite vertex. Okay, but we still use that distance in our formula. So let's try a couple of examples down below. We're going to find the area of each of these triangles. So in example 1, I'm going to go ahead and label my sides. The base would be this side here, which is 11. And then the height is the distance from the base to the opposite vertex, and that's going to be 4. So I start with my area of a triangle formula. Area equals 1/2 times base times height. And in this formula, I'm going to substitute 11 for B and 4 for H. So I have area equals 1/2 times 11 times 4. Remember, multiplication you can do in any order, so I'm going to start by multiplying 11 times 4, and that gives me 44. So now I have 1/2 times 44, and half of 44 is 22. So the area of this triangle is 22. Because they didn't give me a measurement, I'm going to just say units. And remember, area, we have square units. So this is 22 square units. Okay, number 2. We can call either side the base. So I'm going to call this side 8 the base of the triangle. And then the height of the triangle is the distance from the base to the opposite vertex. Well, in this case, that distance is the other side of the triangle. From here to here would be the height. H equals 5. I could have also called 5 the base, and that would have made 8 the height. So either way, I'm going to multiply 1/2 times 8 times 5 using my formula for area of a triangle. So this is 1/2 times 8 times 5. Again, I'm going to multiply 8 and 5 first because multiplication is commutative. So this is 1/2 times 40, and half of 40 is 20. So this is 20 square units for the area of the triangle. Okay, now we're going to talk about how parallelograms can also be divided into trapezoids. So if you look at the figures below, I have a parallelogram on the left divided into two congruent trapezoids. And the area of each trapezoid is going to be equal to half the area of the parallelogram, just like for triangles. A trapezoid, though, is a little bit different from a triangle because a trapezoid has two bases. And the bases of a trapezoid are its parallel sides. So what we usually do for trapezoids is we call one side B sub 1, or base 1, and the other side B sub 2, or base 2. And now if you look at this figure on the right here, you'll see that if I add base 1 plus base 2, I get the original base of the parallelogram. So adding base 1 and base 2 gives me what the original base of the parallelogram would be. So to get the area of a trapezoid, it's similar to the area formula for a triangle. I have to take 1/2 times the height times the base. But for a trapezoid, I find the base of the parallelogram by adding together the two trapezoid bases. So that gives me this formula below. The area of a trapezoid is 1/2 times the height times the sum of the bases. So let's practice using this formula now in examples 3 and 4. We're going to find the area of each trapezoid, and I'm going to first of all identify what my dimensions of the trapezoid are. So I need three things to find the area of a trapezoid. I need base 1, I need base 2, and I need the height. Well, base 1 on this trapezoid, I can pick to be either 8 or 14. Remember, the bases are the parallel sides, so it does not matter which one's which. I'll just go ahead and call base 1 14, and that means base 2 is going to be the opposite side, 8. The height of the trapezoid is the distance from one base to the other, so in this case, the height is going to be this imaginary line, or you could also refer to it as this side over here, which is 6 feet. So notice we have this other side that's labeled for this trapezoid. This side over here we're not going to use in the formula. It really doesn't matter, the 8.5 feet. It's unnecessary information, so I'm not going to use that. I'm just going to use my two bases and my height, and now I'm going to go ahead and substitute these values into my formula for area of a trapezoid. So it's 1/2 times height times base 1 plus base 2. So this is 1/2 times 6 times base 1 plus base 2. Base 1 plus base 2 is 14 plus 8. And now I'm going to do order of operations. So I start inside my parentheses. 14 plus 8 is 22. So this is 1/2 times 6 times 22. I'm going to, in this problem, take half of 6 first, since that's an even number, or that gives me a whole number. 1/2 times 6 is 3, so now I have 3 times 22, and 3 times 22 is 66. So the area of this trapezoid is 66. We're measuring in feet, so that would be square feet. Okay, number 4, let's do the same thing. Label our base 1, base 2, and our height. So base 1 for this trapezoid I'll call 15, and then base 2 is going to be the opposite parallel side, that's 19. The height is the distance from one base to the other, and that's going to be 11. So to find the area of this trapezoid, again my formula is area equals 1/2 times height times the sum of the bases. So this is going to be 1/2 times 11 times the sum of 15 and 19. I need to figure out 15 plus 19 first. 15 plus 19 is 34. So this is 1/2 times 11 times 34. I'm going to multiply 11 times 34 first here. So 11 times 34 is going to give me 374. So this is 1/2 times 374. And remember, multiplying by 1/2 is the same as dividing by 2. So now I'm going to take 374 and divide it by 2. And so if I do some quick long division here, you can see that I get 187. So the area of this trapezoid is 187 square centimeters. All right, if you had any questions over this video, make sure you have those written down for the next time. And until then, have a nice day. You're all wonderful people.